Hello viewers, welcome to Class with Ike. For today's class, we're going to be looking at the Haber cycle. Okay, now the Haber cycle is just a special case of the Hens law. Alright, that no matter the route in which you're using forming a particular chemical substance, the enthalpy change is always the same. That is, the summation of the energy, the summation of the heat energy will always remain the same. Okay, that's the Hens law. So today we're going to be looking at the Haber cycle, and the Haber cycle is just talking about the formation of a solid crystal structure, usually an ionic substance, is an ionic solid. For example, sodium chloride or magnesium chloride is salts that contains a positively charged ion and a what negatively charged ion as well. So we're going to be taking an example today. We're looking at magnesium chloride, and also looking at what sodium chloride. So we'll start from the first one. Let's start from magnesium chloride. Okay, so now when we are looking at the formation of magnesium chloride, magnesium MgCl2, that is the compound, is written as MgCl2, right? So I would like to write a kind of acronym, FAIL. The F represents the formation, the A represents the atomization, the I ionization, and this is the lactic energy. Alright, okay. As I go on, I will be defining these terms. So you have the formation, the atomization, the ionization, and the lattice energy. Alright, so let's move on. So how do we get magnesium chloride? Now I want to separate this to the constituent molecules, that is magnesium solid and what? Chlorine gas. Alright, now once we're done, so we're going to have the heat of formation to be here, delta HF. That's the heat of formation of magnesium chloride. Alright, now once you're done with this, next is to now atomize each of these molecules, change it to its atomic state. Alright, so we have magnesium will sublime. Okay, so this delta H atomization, so it's also called sublimation because solid is changing into gas. So we have the Mg gaseous state. Then also the chlorine will become atomized as well. You can also call it bond dissociation. So delta H of atomization can also be called bond dissociation. Alright, so it changes towards to also an atom. But if you look here, we have okay, the equation is balanced. That is, we have two atoms of what? Chlorine here. So we'll put a 2 here to signify the two atoms of what? Of chlorine. Are we together? So the Mg plus Cl2 gives us a balanced what? Equation down here. That is MgCl2. Okay, so it is 1 mole of magnesium solid reacting with 1 mole of chlorine gas. That is balanced. So, but because of this is Cl2, that is Cl2, that's how the bond looks like. So there are two atoms in a molecule of chlorine gas. So that's the reason why I'm putting the 2 here. So to balance it, so that is 2Cl, because we are moving from a gaseous state to an atomic state. So a gaseous atomic state. Alright, so now what you're going to be using here at this level, that is atomization level, you'll be giving the value of the enthalpy at this stage. So you're going to be adding up the enthalpy. So usually you'll be given the enthalpy. Alright, so now after you've gotten to the atomization state, you move now towards the ionic state. That is, you're going to convert each of these atoms to an ion. Alright, so the magnesium, of course, magnesium will lose 2 electrons to become magnesium 2 plus. Alright, so the 2 electrons means that it's going to have it losing two electrons means that it's going to have two ionization energy, which is the first ionization energy and the second one. Because when it loses the first electron, it will absorb an energy, or it is requiring an energy to take out the first electron. And once that is done, then it's also absorb another energy to take out the second electron. So ionization energy is the energy that is required to remove the valence electron from a what? From a neutral atom in gaseous state to make it what? A positively charged ion. So here is losing two electrons. So the first one will require the first ionization energy, and the second one will require the second ionization energy. So right here, my delta H ionization energy will be equals to the first one plus the second one. Okay, the first plus the second. Now in this case here, the chlorine will also be ionized. Okay, will also be ionized. But chlorine is only needing what? One electron, and this is called electron affinity. At this level is called electron affinity. Okay, because electron affinity is the energy that is released whenever an atom in gaseous state absorbs what, or attracts electron to become a negatively charged ion. So here for the non-metal, or the chlorine gas atom is going to absorb, is going to release energy because it's what? Attracting electron. Okay, it's going to release energy because it's attracting. So chlorine will attract electron to become what? Chlorine minus. But if you look here, there are two atoms, because magnesium is ready to give out two. So there will be two chlorine to collect the what? Two electron to become two Cl minus. Okay, so that is what is happening over here. So there will only be one ionization energy, not two, because it's just one negative. So it will be one ionization energy. So that will be equal to the ionization. Sorry, to be one electron affinity, not ionization energy. Yes, electron affinity. So it should just be just for one or the first electron affinity. So we're not having any second one. So once we are done with this, so the next step is now to have our lattice energy. Okay, our lattice energy. But now if you look here, we have two. So whatever we get here, we are going to multiply by 2. Let's not forget that, because there are 2 moles. So whatever the value you have for the what? For the electron affinity of the chloride ion, whatever the value you have, you're going to multiply by 2 because of the 2 moles that is present here. Hope you get that. So because of the 2 moles that is present here, you're going to multiply by what? By 2. Hope that is clear. Okay, so once you're done with this, then you have your lattice energy. Now the total formula to calculate, or to use in your calculation, will be the heat of formation, which is this one. That is the heat that is usually involved whenever a particular compound is formed from its constituent elements. Okay, so the heat of formation plus the latent heat, the lattice heat, sorry, is equal to the heat of what? Atomization. Both are atomization, but this can also be called sublimation, and this can also be called bond dissociation. So plus the heat of ionization plus heat of electron affinity. So this is the formula you have to use. So usually you'll be given others, why one will be omitted for you to find. You'll be asked to find one of them. So depending on the question, you will now know the one they're going to make the subject of the equation. Okay, so let's go again. The formation involves the coming together of the molecules to form the compound. Then from each molecule, you are going to what? Atomize it. That is, change it to its gaseous atom. So for this it is sublimation, while for this is bond dissociation. Okay, so there are 2 chlorine here, two chlorine atoms here, so that's why the 2 is here, because you cannot have a number that is down here. No, it is an atom, just a single atom, so nothing should be down here. That is why the 2 that is here will be used as a mole. So 2 moles of what? Chlorine atom. So here there is 1 mole, so that's the reason why this remains the same. So I did not multiply the bond dissociation by any number. Likewise, I did not multiply the atomization, that is the sublimation, by any number. So on getting to the 2Cl minus, I had to multiply, because the 2 atoms of chlorine gas, was what? Was accepting or attracting 2 electrons, so from 2Cl minus. So each of those atoms we have its own electron affinity. So since there are 2, you multiply by what? By 2. So this is all we have. So let's take a look at sodium chloride as well. Alright, so now for sodium chloride, we have NaCl. Alright, so we're trying to form that. Let's bring it down a little bit. So this is our delta H of formation. Alright, so it is formed from its constituent element sodium plus chlorine gas. Alright, now you can see here that chlorine here in the compound is just 1 atom. Alright, so we need to balance the equation by using half here. Alright, so from here we have the atomization stage, delta H of atomization. So we'll be given the value. Usually we give you the value, or you have to find it depending on the question. Alright, so then we also have this also, delta H of atomization or bond dissociation. Alright, so usually you'll be given or you'll be asked to find, but you can see here that it is half of the Cl2. So we need whatever value you are given, you need to multiply it by what? By half. Okay? So you divide by 2. Alright? So once you break the bond, it forms what? Cl gas. You can see that. So we are getting the atom, because if you have 1/2 times 2Cl, it gives you what? 1/2 times 2 atoms of chlorine, it gives you just 1 atom of chlorine. So that's what I did here. So we're going to have 1 atom of chlorine over here. So, and it should correspond with your final product. So 1 atom of chlorine, 1 atom of chlorine. Okay. Then the sodium as well, we have Na. Okay, in gaseous states. This is in solid states, while this is in gaseous state. So you've been able to sublime. The sublimation has taken place, also called atomization. Alright, now from this stage we need to move to the what? To the ionization state. So we have delta H ionization. So you'll be given the value, or you can check it on your data booklet. Alright. So the next one here is also of electron affinity. So here sodium will lose 1 electron, so we only have one ionization energy here. So there is no need for a second ionization energy, because it's just 1 electron that is being removed, and this also will accept 1 electron, so just 1 electron affinity as well. So you'll be given the values here. So we don't need to multiply here because it's just 1 atom. Okay, 1 atom and 1 atom. So you're not multiplying. The next thing here is to get our lattice energy. Using the formula I gave earlier on, you can be able to find any value. So the major things for you to know is to how to draw your circle and then apply the formula in finding anything you are looking for. Alright, so thank you very much. We'll see you in the next class.